Um, you learned about the complements. So let me explain something. Complement of a set is all the elements that are not in the set. So all the elements of the universal set that are not in that set. And the notations are complement of A would be either A bar or A prime or A complement. These all three notations represent the same thing. It's unfortunate that we have three different notations, but as the math evolves, set theory evolves, these three were adopted by different people and ended up being acceptable notation for the same thing. So remember that all three represent the same thing. So the first question here, part A, says, according to the problem, universal set has all the numbers from 0 to 7. A has 0, 2, 4, 6. So the first question is, what is A bar? Okay, so these are fairly easy questions, so we don't have to spend too much time. Just somebody can tell me what would be in A bar. Well, we can move on. A bar would be.
Oh, sorry. I can go.
Yep, go ahead.
1, 3, 5. Yeah, that's it. 1, 3, and 5.
Okay.
And 7. I did not see 7 and 7.
And 7, right. 1, 3, 5, 7. Everybody agree with that? Yes, that is correct. Okay, we move on to part B. It says A prime intersection C. Now, for that, you need to find A prime. We already have A prime found in the previous part. A prime and A bar are the same thing. So A prime intersection C is the question. Somebody has question. Karina, you still have question?
Oh no, my hand was just raised.
Okay.
Sorry.
Anthony?
Yeah, is it 5 for A prime intersection C?
Okay, A prime intersection C, 5 is correct. So remember, when there is only one element, it doesn't mean you can just write 5 like that. Then it's not a set. A prime intersection C is a set. So you had to have a set on the right side. A set would be curly bracket 5, curly bracket containing 5. You have to write that curly bracket, otherwise it's wrong. Okay, very good. Let's go to part C. A union B prime. For that, you had to first find A union B. Okay, can somebody tell me what A union B is?
Would it just be 7?
No, union. Union means?
It will be everything in A plus everything in B. Well, you have to eliminate the 2 and...
Yeah, you don't list things twice. Other than that, you need to list everything in A and B together. So there'll be 0, 1, 2, 1, 2, 3, 4, 6. Okay, everybody agree? 0, 1, 2, 3, 4, 6. Now, the question is A union B prime. So I need to find the complement of this. Okay, can somebody tell me the answer to that? The complement of this set, the set we have right here, we need to, this is A union B. So find the complement of that.
2 and 4.
What's that again?
2 and 4.
2, 1, 4. No, complement would mean everything that is in the universal set that are not in the set A union B. That's what complement means. Okay. A union B complement means everything outside of A union B. So what elements of the universal set are not in here? That's the question, basically.
Five and seven.
5 and 7, yeah, very simple. 5 and 7. Everybody was quiet for a while. Is there something you're not understanding? Feel free to ask the question. Part D is A intersection B prime. So to do that, I have to find A intersection B first. Okay, can somebody tell me what A intersection B is?
2 and 4.
2 and 4, right. Okay, 2 and 4. Now tell me what would be the complement of that. Universal set is right here. So all you have to do is look at the universal set and find out what are the elements there.
So essentially, it's the numbers that are not 2 and 4.
Numbers that are not 2 and 4, yes.
So 0, 1, 3, 5, 7.
3, 5, 7. Yes, exactly. That is correct. Okay, someone created a sticker note. All right. Part E is A union B prime. Okay, so what should I find first? I had to find B prime first. I'm trying to find A union B prime. So B prime is needed first. That means complement of B. Okay, what are they?
0, 5, 6, 7.
Right, 5, 6, 7. A union B prime. That means we already have the B prime here. We need to combine that to A and list all the elements. What are they?
So list all of them is going to be 0, 2, 4, 6,
5, 6.
5, 6, and 7. Yeah.
Yes. You don't really have to write them in order, but if you write them in order, you won't miss anything. For that reason, I prefer to write them in order, but you can write them in random order. Okay, that is correct. Part F is A union B intersection C prime. So where should I start? I should start with the B intersection C and then find prime of that. So what is B intersection C? Anybody?
4.
Just 4, right. Okay, and next step is to find the complement of that. What are they?
0, 1, 3, skip 4, and then it's 5, 6, 7.
Right, right. That's the intersection C prime. And now I need to find a union with this set, the intersection C prime. So I'm going to have to combine A to this. A has a 4 and everything else A has is also here. And A has a 4. That means the union is going to be 0, 1, 2, 3, 4, 5, 6, 7, which is same as the universal set. A union B intersection C prime is same as universal set. Okay, part G. I'm going to delete this frame 16 here. Okay, moving to part G. So A union, B union, C prime. That means I have to find A union, B union, C first. A union, B union, C. I think somewhere earlier we found A union B. Yes, in part C, we found A union B. It's right there. This is A union B. So I need to combine this with the C to get A union B union C. Okay, what do we get?
It's still just 1 through 6. Or do you add the 7? Well, 0 through 6.
Yeah, C has 4, 5, 6. So 0, the 5 will be added to this, right? To A union B. When I combine the C, the 5 will be added. Nothing else will be added. 4 and 6 are already there. So 0, 1, 2, 3, 4, 5, 6. Not the 7. So it's not equal to universal set. 7 is missing. We need to find the complement of this.
7?
7 is correct. Very good. Just 7 is all we get. Okay, very good. Let's move on to number 2. The following Venn diagram shows the points in the sets A, B, and C. So the dots are labeled. Each dot is labeled, and those dots are in those sets. For example, the set B has X, W, R, V. All of them are in set B, just for an example. The question says, list the points that belong to each of the following sets. And part A is B intersection C. Okay, can somebody tell me what points are in B intersection C?
Is it W and R?
W and R is correct. Very good. Yeah, so you write the answer by listing a set containing WR. Okay, part B, A union B intersection C. Okay, you can identify A union B intersection C first. You learned in the lecture video how to identify the set. A union B would be A and B together. So that would be these two circles. I cannot select them. Okay, the circles representing B and the circle representing A, the circle combined will be the A union B. Now, what part of that is common to C is the question, right? Which elements are there in that area? Anybody? Which points are in the area that is A union B intersection C?
R?
Only R? No, not really. So let me draw on the board and show you A union B intersection C. So here's the universal set. B and A are these, B, A. Now, the union of these will be both circles together. Both circles, all the points in these two circles together. So let's ignore the picture in the problem and use this picture. Now, C is another set. So what part of A union B is also shared with C? I'm going to shade that region. What part of A union B is shared with C?
That whole middle section from like
This,
yeah, exactly.
is it just this?
No, it's up. Go up too. Go up a little bit.
Go up?
Yeah. Does that count or no?
No,
Ah, wow. All right.
this is not in C. Anything here is not in C, right? We need to be in A union B and in C, right? Common. So none of these are in C, so they don't count. So what I have shaded right now is not correct answer. Anybody? we can approach it slightly differently using colors. A is this, B is this, and so B and A are these. And if I combine B and A, then I'm shading A union B. Everything in red is A union B. Now, C is right here. So basically, when I say A union B intersection C, to find A union B intersection C, A union B is red. It's shaded red already. So the question you ask is, what part of C is also red? See, what is common to A union B and C is same as saying, what part of C is red? You know, what is common to A union B and C is what part of A union B is also in C. That's same as saying, in this case, what part of red is in C. Isn't that this part right here? Right? This is the part of red that's in C. In other words, A union B intersection C is all of this. Everybody understand that? Okay.
Yeah, I get that.
Okay, then you can answer the question in the problem. The problem says list the elements that are in A union B intersection C.
WRU.
W, R, and U, yes. So A union B intersection C has W, R, U. Okay. There is one more question, A union C bar. Okay. A union C bar. Can anybody find the answer now? The complement of A union C has what elements?
So that will be basically R and U, right? Or would that be opposite?
R and U.
So would it be everything in C and everything in A?
That would be the A union C, but what we are trying to find is complement of A union C. Complement, everything that is not in A union C. Okay,
So what is it? X?
is it
Or
only, is it only X?
would it be V? No.
No.
X, S, and I? I didn't even know those were points outside.
S and
I, or is that L?
there's no I.
There's a T?
T, that's a T.
Oh, okay.
Yeah, you're right now. A union C complement will have the Y, S, and T.
Y, S, and T.
Okay, everything outside of, oh wait, A union C, sorry, not Y, X. A union, I was doing B union C. A union C complement, see, A union C is, let me draw that on the board. I can't do anything in that picture. So I had to draw my own picture. So A union C, this is B, A, and C. So A union C is what I'm shading, everything in A and C combined. This is A union C. So complement of this is everything outside of it. So can you see that the X is outside of that, right? And the T is outside the shaded region. And the S is outside the shaded region. So the answer is X, T, S. Any question on that?
Nah, I'm good.
Okay. Okay, the problem number 3 says, show the following relationship of the sets A, B, and C on a Venn diagram. And the part A is C is subset of A intersection B. So how would you show that on the Venn diagram, this fact? Let me see if you can now use your own space to write the answers. Everybody created a box, a frame to work on. Please create a frame and show the answer for number 3. You're drawing a Venn diagram that will show the fact that C is a subset of A intersection B. All right, let me explain something before that. How do I show on a Venn diagram that A is a subset of B? Let me show you. To show that A is a subset of B, A is a subset of B means every element of A is in B. That's when we say A is a subset of B. Every element of A is in B, but it doesn't have to be the other way around. That means, for example, if A has 1 and 2 and B has B equal to 0, 1, 2, 3, then everything in A is in B. So that's when A is a subset of B. On the Venn diagram, when I draw B, a circle for the B, that means every dot here is an element of B. That's what B, the set is B means. Now A is a subset of B means, A is a subset of B means every element of A must be in B. That means all the dots that represent A must be in B. That means in the Venn diagram, the A has to be a circle inside B. Only then every dot in A is also in B. Okay, so if I want to show that so this is a Venn diagram showing the fact that A is subset of B. Let me show you another Venn diagram. A intersection B is empty. Show this fact on the Venn diagram. If A intersection B is empty, what that means is empty. Phi represents empty set. Empty set means a set containing nothing. So A intersection B has no elements, means there is nothing common to A and B. And to show that fact on this picture, I can draw 2 circles sharing no elements. This means A intersection B is empty. So you saw similar examples in the video, lecture video. So in this problem, it says C is subset of A intersection B. Now we can draw A intersection B on a Venn diagram. You saw that in the lecture video. I can quickly recall that. If I want to show A intersection B on the Venn diagram, A intersection B is everything common to A and B. This is A, this is B. Then this is A intersection B, the elements that are common to both. Okay, now you should be able to answer that question. C is subset of A intersection B. You need to show that fact, so that information on the Venn diagram. Okay, I'll give you a few minutes clearing up my work area.
Professor,
Yeah.
I did not get the mirror invitation.
I sent an email message with a link to everybody. You didn't get that email?
You talking about the previous one or
No,
today?
today. There's
No.
an email I sent you today.
I'm looking at my emails and it does not like have something similar to it.
You have to look at the email that you used with the Blackboard.
Let's see.
Are you looking at the right email address? Are you looking at the right mailbox for the John Jay? I don't know whether it's John Jay email or not. Whatever email you used.
I got it. Thank you.
Okay, all right.
Thanks.
Looking for answers. I don't see anything. No, Rocio Reyes, what you have highlighted here is A intersection B intersection C. That's what that is. That's not what the question is. The question says there's a fact given to you. C is a subset of A intersection B. So to represent this fact, how would you show the sets A, B, and C if to illustrate this fact on the Venn diagram? How would you draw those circles? So what you have is not the answer to that question. Daniel DeBoer, I'm looking at your solution. What you have drawn here says that the fact it represents is the fact this picture represents is A union B subset of C. What you have is A and B, both circles are inside C, means both A and B are subsets of C. That's what that means. A union B is subset of C. That's what your picture represents. That's not the fact given to you. C is subset of A intersection B. That's the fact. So this is wrong. Please put your name on the frame. Otherwise, I wouldn't know who is who. Uh, Janice, you're just drawing without using a frame, so I won't be able to identify your work if you don't use a frame. To create a frame, you just have to click at this icon here and change, and then click in the area. I can create a frame for you. I'm creating a frame for I think it created a frame somewhere. Frame 20. All right, I'm changing the name of this frame. All right, so here is the frame for Janice. Okay, I see Nicholas. You're close, but not quite right. C is a subset of A intersection B, means C, every element of C is in the intersection of A intersection B. Subset doesn't mean it's equal. C is subset of A intersection B. So Nicholas' picture is close, but not right. Karina, you shaded the intersection. That picture only shows intersection. That's not correct. Anthony, your picture, Anthony Rodriguez, your picture means, your picture illustrates the fact that C is a subset of A. That's all it says. C is a subset of A, which is not our statement, which is not the fact we are trying to represent. Excellent. One student has an answer. I don't want to say the name yet. One student has it right. Two students have the right answer. All right, let me tell you who has the right answers. Rocio Reyes is correct. You can see the picture right now. And okay, Jaden Garnier is also correct. And Sinead is correct. So those three students have the right answer. So let me explain on the board. I'm going to draw, I'm drawing my answer here. So here is the universal set. That's the universal set. And I'm going to draw the circles for A and B first. And A, according to the problem, there's A intersection B. That means A and B has something in common. So when I draw the picture for the A and B, I should let them intersect each other. And that's what I'm doing. They have a common area now. Okay, so what is A intersection B? All right, this is A and this is B. A intersection B is the common area right here, the middle, these points. C is a subset of A intersection B, means all elements of C should be inside this intersection of A and B. So that means C has to be somewhere here. That's what this is your picture. That's your answer for the problem. Okay, that's part A. Now, part B, I want you to do it first. Clear the picture you already have, erase everything, and then do the new work, do the work for the new problem. Part B. You're doing part B, 3B. Manual, manual, I think you have the answer for the previous picture still on there. You may want to remove that. And
Got it.
if you keep the picture for the other problem, it'll be confusing to me. Karina, if your picture is supposed to be the answer, then it's wrong. C is supposed to be a subset of A prime intersection B. So you first have to identify what is A prime intersection B. And C has to be a subset of that. Okay, I see one student has the answer right. Okay, 2 students, 3 students have it right. 4 students have it right. 5 students have it right. Okay, so I'm going to now say who is right. Yolani Cabrera is right. Sinead is right. And Nicholas Obadick has the right answer. Daniel DeBoer. There was one more. Rocio Reyes, yeah, okay. Okay, very good. That's, and Anthony Rodriguez has the right one. So that's very good. Everybody's improving. So let me explain that. To answer that, the C is a subset of A prime intersection B is the fact that we want to show. So you need to first identify A prime intersection B. So I'm going to do that part first. This is A and this is B. A prime is everything outside of A. So what part of outside of A is also in B? See, A prime intersection B means what is common to outside of A and B. The area common to outside of A and B is this, right? Now, these were simple examples that I did in the lecture video. So you saw that this is A prime intersection B. Because A prime means outside of A. And so the question is, what part of outside of A is in B? And that's this, clearly. Okay, so now I'm answering the part B of the problem. Part B of the problem says C is subset of A prime intersection B. A prime intersection B is this part. And C is subset of this means C has to be a circle in here. C is here. So that's how you show the Venn diagram representing that fact. Okay, now the question number 4 says A is already given to be subset of B. If A is already subset of B, then what can you say about A intersection B? You can describe this as a set. You can write that this is equal to something. And that this is equal to what? Anybody? A is already subset of B. So A intersection B would be what? Let me give you a hint by drawing the Venn diagram that represents the fact that A is a subset of B. This would be B, and A is subset of B means A has to be inside. All the points of A are inside B. So this is A, and it's a subset of A. The fact that A is subset of B is shown on the Venn diagram this way. Now, can you tell me what A intersection B would be equal to? Anybody can tell me the answer?
Would it be A union B?
A union B will be combining A and B. So if you combine A and B, that would be when A is inside B. Oops, sorry, that's the wrong picture. No, A union B is a wrong answer. I'm trying to explain why it's wrong.
Would it be U, like universal?
No. A is subset of B. I have shown that in the picture. So think about what A intersection B would be. What's the meaning of A intersection B? And if you think about that, you will be able to tell what this is equal to. You can write that this is equal to something. And that's your question. A union B is the same as A and B combined. So A intersection B can never be equal to A union B. So that's not correct. But look at this picture. A is inside B. Then what can you say about A intersection B? That's our question. Normally, A intersection B would be the area common to A and B, right? So if A and B are circles like this, then A intersection B, the area, the elements that are common to A and B are these, right? So when A is subset of B, what happens to that intersection? Anthony, you have hands raised. Does that mean you have an answer? Or
Wouldn't it be everything outside of A and B?
everything outside of A and B? In this picture, everything outside of A and B would be this. Are you saying that's equal to A intersection B?
Wouldn't you highlight all of A then? And the intersection?
Right. So that means Anthony Rodriguez said that. Okay, that means what do I write here for A? What do I write next to the equal sign here?
Would it be B prime?
No.
It-
You already figured it out. And
So he would just write A subset of B.
A
So it
is
can-
subset of B, so therefore A intersection B will be equal to something. And what is that is my question.
Would it just be A?
A, exactly. That's the answer. Why? Because see, what is common to A and B is all of A now. Everything in A is in B, right? So everything in A is in B means common area for A and B is all of A. You can see in the picture, right? All of A is common to A and B. So A intersection B is same as A. That's, I mean, I'm glad at least one student got that right. See if, let me draw that picture again to make sure you understand it. This is B. And if A is something like this, then the common area would be your answer. But A is not something like that. A is entirely inside the B. So that means what? A is like this. So what area is common to A and B now? A is inside here. So what area is common to A and B? All of these. Because all of these are in A, in B, in A and in B. So the answer is A itself. The next question is, what can you say about A intersection B prime? A is a subset of B. So my picture is still correct. A is a subset of B. So what can you say about A intersection B prime?
Wouldn't it also equal A?
No, B prime is outside of B, right?
So this time it will be everything outside of B.
B prime
Outside of E.
is outside of B. So here is B. The A is still subset of B. So A is entirely inside B. B is here. B prime is this. B prime means outside of B. right? A intersection B prime is the question. A intersection B prime is same as common area between A and B prime. What can you say about that? The common region between A and B prime. Here's A, here's B prime.
I don't see no common area.
Right,
So it's phi?
Yeah. That's the answer. So what do we, when there's nothing in it, what's the notation for it?
Phi.
Phi, exactly. That's the answer. Empty set. A intersection B prime is phi. Empty set. Everybody can see that there is nothing common between A and B prime. A is here. B prime is all this. And there's nothing common between them, right? So the intersection of those is empty. That's when you use phi to identify the answer. So yes, so those are the answers for that. Okay, so that's all I needed to do today. So, you know, I know the meeting, this attendance to this meeting is not required to pass the course, but all these students who come to this class and go through this practice will definitely do better because you are practicing with more problems. Now you're going to do better in the homework, you know, than others. And that's why I strongly advise you to come to this class and join this practice. You are, you know, all of you who are attending this class are expected to do better than those who are not attending, because you are doing more, you're learning more, and you're getting all your questions answered. That's how you learn math. All right, anyway, any other question that I should answer?
Can you check in your private chat? I sent you a message.
You sent a message, okay. Sorry, when I check the message, it's going to show up on the screen. I have office hours at 3 o'clock. Is that going to work?
Okay, but do I use the same link, this link?
No, on the Blackboard, there is a separate link for the office hours.
Okay.
Use that link to visit office hours at 3 o'clock. Okay?
Okay.
All right. Anybody else? All right, in that case, yeah.
No, I was saying no, I'm good.
Okay, all right. Okay, then we will close and meet again on Wednesday. And I have office hours at 3 o'clock, and there's a separate link for the office hour meeting. Use that link to join the meeting if you have questions or any concern.
Hey, are you gonna post the recording today on Blackboard or no?
I didn't bother to do that because this discussion, you know, it's not useful watching on the video. I didn't.
Oh, okay, cool. No, it's cool. I just wanted like to rewatch the previous one and write them down, because for me, when I write things down, I just remember easily. So I just wanted to write it down instead of.
Okay, so you think this video will be useful if I post it?
Yeah, for me.
Okay, I can do that.
Thanks.
Yeah, you know, it takes a long time to process and everything, so it's kind of work for me, but I don't mind doing it. All right, I'll post this video, today's one, for you. Anything else?
Nah, thank you so much, Teach.
You're welcome. All right, everybody have a good day. Enjoy the rest of the day. I'll see you Wednesday.